How can we assign global IPv6 addresses to our end stations? Well, like IPv4, we have DHCP for IPv6. So that is one option. But I don't want to show you DHCP. I want to show you this other feature called Stateless Address Autoconfiguration, SLAC for short. What does SLAC do for us? Well, SLAC allows our devices to automatically generate their global IPv6 addresses. Now, how are they going to do that? Well, let's analyze R1's interface right now. So I'm going to type in show IPv6 interface gigabit Ethernet 0/0 right now. This router interface of gigabit 0/0, this one right here, that interface has an IP address of 2001:DB8:1:A:1. But what is its prefix? What subnet does it belong to? It belongs to the 2001:DB8:1:A:/64 prefix. And that's exactly what it shows us in our diagram as well. So since I have a router and its interface is in this prefix, doesn't that mean that everybody connected to that router interface should be in the exact same subnet/prefix? Yeah, there's no difference between IPv4 and IPv6 when it comes to that. If I want PC1 and PC2 to successfully communicate to the internet, well, they're going to have to go to their default gateway. Well, their default gateway has to be in the same subnet they are. So the same rules apply to IPv6 as they apply to IPv4. So if that's the case, why not have my router tell the PCs, this is a subnet I belong to, and then let the PCs automatically generate their interface IDs, the latter 64 bits. And because this information, this prefix information came from the router, then the clients can automatically assume that that router is their default gateway. Meaning that the clients can immediately get an IPv6 address, a global IPv6 address, the prefix that goes along with it, and the default gateway for their local area network without even ever needing to talk to a DHCP server. So how do we make this happen? Well, rule number one is that the prefix must be a /64 as we see here. If it's anything else but a /64, it will not work. So /64 is an absolute must. And we have that. Number two, IPv6 unicast routing must be enabled. Because there's no way I could be a router, a default gateway, forwarding packets unless I have IPv6 unicast routing enabled, unless I've been configured to route for IPv6 packets. So we have to turn that on. And right now, we do that by simply typing in IPv6 unicast routing in global configuration mode. Now, before I hit enter, I want to step out to PC1. And when we analyze PC1, we're going to look at the output of ipconfig. Notice that for the adapter of PC1, that's the one we're focusing on, there is an IPv4 address, subnet mask, and default gateway. But there's also a link local IPv6 address. I did not, let me repeat, I did not create that. So why is that here? Well, it's because IPv6 is enabled for this device by default. Let's go over to our PC adapter settings. Go into our properties. We'll see here that TCP IPv6 protocol suite is installed on this device. As a result of that, it's ready to go. Every single interface that is enabled for IPv6 automatically generates its own link local address. Its link local address. So that's why we have that here. But I want you to notice something. Starts off with FE80, and then we have the rest of the values. How were the rest of the values derived? Well, we know that our routers can use EUI64. the PCs can also use EUI64. But does Windows implement EUI64 by default? And the answer to that is no. You see, my client PC1's MAC address ends in 06D6. Let's take a look at that. I'm going to use the command ipconfig switch all, and we'll see here that for that particular interface, the MAC address ends in 06D6. Well, when we look at the IPv6 link local address, that's not even close to being the exact same. It's not even close. So how was that generated for the link local address? It was just randomly chosen. Windows, Microsoft has built into their operating systems, Windows 7, Service Pack 2 and above, so Windows 8, Windows 10, all follow this now. They use a random generator to come up with the latter 64 bits of the IPv6 address. Now you can through some setting changes, reset it back to using EUI64 if you want to. There is the possibility to do that. So if you want to use EUI64 on all of your clients, just search out on how to do that, and you'll be able to figure out how to get that back to EUI64. But if you're all looking at this going, well, hey, this is not EUI64, that's the reason why. It uses a random generator. Microsoft wanted to avoid having MAC addresses used as the latter 64 bits of the IPv6 address for security reasons. So they said, let's go with a random generator. So that is why that is there. But what I want to do here is I want to get that global address. I want to get PC1 to have the global address, and I want it to use stateless address auto configuration to do so. Now, all of our end stations are designed with IPv6 to use stateless address auto configuration. So that's their first go-to. I don't have to do anything. Slack is on by default. So here's what occurs. Our end stations, by default, are going to wait for router advertisements to arrive. So the router advertisement has that prefix information in it. It's designed for Slack. The PC saying, all right, I'm waiting for that router advertisement. If it doesn't hear a router advertisement, it sends a router solicitation message. Keeps sending out router solicitation messages saying, hey, is there a router out there? Hey, is there a router out there? Hey, is there a router out there? So it keeps asking for a router. So the router, if it's there, will respond with a router advertisement. And if a router doesn't hear any solicitation messages on regular intervals, it will send router advertisements anyways to make sure that everybody on the network or any new device that's connected to the network gets the addressing information that it needs. So this is all based on the router advertising its prefix and its own link local address in order to get the job done here. So what we're going to do here is we are going to now enable IPv6 unicast routing on R1 and then sit back and do nothing, because it's going to automatically perform the process that needs to be done. So here we go. Let's go ahead and do that.